Okay, so in this lesson, we're going to solve rational equations. And as you go through the process of solving these rational equations will lead to linear equations. And in another lesson, these rational equations will lead to quadratic equations. But for these problems only, they're going to lead to linear. So it's going to be an easier lesson to understand than if it were leading to quadratic. But before we actually get into this part of the lesson, we have to review something from a previous course. And what we need to review is the idea of restrictions for rational expressions. So again, this is going to be a review. So let's talk about what rational expressions are, or remember what they are. So a rational expression is the quotient of two polynomials. And then here are some examples. So some examples of rational expressions are, the first one, x minus 6 divided by 2. So notice you have a quotient. If you look at it, it looks like a division. You have a polynomial divided by a polynomial. Yes, even a number is considered a polynomial. So remember, polynomial is one or more monomials, monomial. So here you have two terms, so that's a binomial, and here you have a monomial. In the next example, notice this time that when you look at this rational expression, the denominator contains a variable, so that's going to contribute to the idea of restrictions. And again, here's another example. Now, here you are going to have to remember how to factor. So if you took this course or the progress of this course a while back, you may want to go back and review some factoring concepts. So I did put these factoring concepts in Canvas. So you need to go back and review factoring. So there's a whole chapter on factoring in the previous course. And then over here, you have another situation. Again, you are going to have to factor. So notice you have a polynomial divided by polynomial. This is a binomial. This is a trinomial. And it is going to involve some factoring. Okay, now, rational expressions indicate division. And remember, division by 0 is undefined, so you can't divide by 0. So, for example, 7 divided by 0, if you put that in your calculator, you're going to get either an error or something. So that's undefined. Okay, undefined. Now, you can have 0 in the numerator. So if you put that in your calculator, 0 divided by 7, you will get 0. All right, so you just can't have 0 in the denominator. Okay, so since we know that we cannot divide by 0, when we are dealing with rational expressions, we must exclude numbers from a rational expressions domain that makes the denominator 0. All right, so we have to determine what values of the variable makes the denominator 0, and we have to exclude it from the domain. All right, now you may have forgotten what a domain is. So the set of real numbers for which an algebraic expression is defined is the domain of the expression. All right, so the set of real numbers for which an algebraic expression is defined is the domain of the expression. Okay, so let's look at some examples. So in these examples, there will be 3 examples. And then in these examples, you want to find all numbers that must be excluded from the domain of each rational expression. All right, so the first one, you have the rational expression 7 divided by x minus 8. All right, so now keep in mind that you cannot divide by 0. So all you have to look at is the denominator. You don't have to look at the numerator at all, because remember, you can't have 0 in the numerator. You just can't have 0 in the denominator. So all you have to do, recall, is look at the denominator, and in this case, this one's easy, and determine what value for x makes that denominator 0. Well, if you look at it, 8 minus 8 is 0, so that means that x cannot equal 8. But when we get into more complicated situations, what you want to do is set the denominator equal to 0. So you'd say x minus 8 equals 0, and you solve for x. So you're going to add 8 to both sides, and so you get x equal 8. So what that means is that my restriction, the restriction is that x cannot equal 8. All right, so x can be any other number. So my domain would be any other number except 8. So remember in the previous course when you had to find the domain, you'd say the domain equals the set of x's such that x is a real number, and then x cannot equal 8 though. All right, so you may recall that. But for the restriction purposes, you would just say that x cannot equal 8. Okay, so x can be any other number. In order for this to be defined, x can be any other number but 8. X cannot be 8 because when I substitute 8, I get 7 divided by 0, which is undefined. All right, now let's look at the next one. So the next one, you have 10 divided by x squared minus 25. All right, so all you have to do in this case, remember, is just look at the denominator. So you're going to set the denominator equal to 0. So x squared minus 25 equal 0. And notice that this is a quadratic equation. So you are going to have to factor. So you're going to factor this, set equals 0. And so remember, this is the difference of two squares. So you're going to say x minus 5, x plus 5, and then you're going to set each of these factors equal to 0. So you'd say x minus 5 equals 0, x plus 5 equals 0. And so when you solve each of these linear equations, so notice you went from a quadratic to a linear. So when you solve these linear equations, you get x equal 5. Here you get x equal negative 5. So the restrictions, you would say that x cannot equal 5 or negative 5. So x can be any other number but these two. All right, the next one. So here, again, when x is 0, my numerator is 0, but that doesn't matter. You got to look at the denominator. So all you do is just take the denominator and set it equal to 0. All right, so the denominator equal to 0. And then you factor the left-hand side. So notice it's a trinomial. So we're going to do those two binomials. And so when you factor this, let's see, I want a negative 14, and I want the middle term to be 5x. So remember, if you recall factoring, you have to use the idea that FOIL method, F-O-I-L, the reverse FOIL. So if you don't recall that, go back to Canvas and then go at the bottom. You'll see some the factoring module. All right, so this should be 7, this will be 2, and I need this to be a plus and this to be a minus. All right, so remember, the first thing you have to do is factor this. So when you factor this, you get x plus 7 times x minus 2. And remember, what you're doing now is using the zero factor property. So you're going to set each of these factors equal to 0. And then you would say, so now in this case, since this is linear, x would have to be negative 7. Here, x would have to be 2. So your restrictions is that x cannot equal negative 7 or 2. All right, so that's a quick review on rational expressions, finding restrictions on rational expressions. Notice it does involve factoring in some cases. This one did not. That's easy to see that the denominator is 0 when x is 8. Here, this one might be easier as well, because what squared minus 25 is 0? Well, 5 times itself is 25. 25 minus 25 is 0. That one is a little bit more challenging since it does involve factoring. Okay? All right, now let's go back and talk about the main part of this lesson, which is solving rational equations. Okay, so let's look at the first one. So we're going to solve each of these rational equations. All right, the first equation is 20 divided by a squared plus a minus 6. So again, it doesn't always have to be x. It could be other variables. Plus 6 divided by a plus 3 equals 5 divided by a minus 2. All right, now, so here you have this rational equation. Okay, so you see the equal sign as equation, and it's a rational equation since these are made up of rational expressions. Now, before we continue, we need to determine what the restrictions are. And so you have to look at each denominator and determine what makes it 0. Now, let's go to this one first. So this one's easy to see. So here, you ask yourself, what makes it 0? Well, you can look at this and determine that negative 3 makes it 0. So negative 3 plus 3 is 0. So x cannot equal negative 3. So you say does not equal to negative 3. Here, you can easily see that what makes this 0? Well, what makes this 0 is 2, because 2 minus 2 is 0. All right, now let's go here. All right, now for these lessons in particular, what's going to happen is that if you're having trouble factoring for right now, but you really need to go back to that Canvas course and look at that module. But if you're having trouble factoring, chances are the factors of this are going to be these two right here. All right, so let's see what they are. So I'm going to go ahead and do that on this page, just to kind of show you. So I'm going to rewrite this over. So that's 20 divided by a squared plus a minus 6. All right, now when I factor this denominator, remember you're going to factor this trinomial as two binomials, and let's see if this is going to work. So a plus 3, a minus 2. Now let's check it. So remember FOIL, F-O-I-L. So the first, a times a is a squared. That's this one. The outer, a times negative 2 is a negative 2a. The inner, 3 times a is 3a. And the last, 3 times a negative 2 is a negative 6. When I combine like terms, I can combine these. A negative 2a plus 3a is just a. So I get a squared plus a minus 6, which is what I wanted. Okay, so the factors here are these factors. So all you have to do is just ask yourself what makes each factor 0. All right, well, a plus 3, I already took care of it. What makes that 0 is negative 3. A minus 2, I've already taken care of it. What makes that 0 is 2. So there are only two restrictions, these two, for this equation. All right, now, let's talk about how to solve a rational equation next. So solving a rational equation. Okay, so let's talk about solving rational equations. All right, so again, a rational equation is an equation in which each term contains a rational expression. So notice that this rational equation, this term here, is a rational expression. This term is a rational expression. This term is a rational expression. So just to note, though, that all linear equations are rational expressions, rational equations, but not all rational equations are linear. So you're gonna, as we go through this lesson this week, you're gonna see what I mean by that. All right. Now, rational equations may have what's called extraneous solutions. E-X-T-R-A-N-E-O-U-S. Extraneous solutions. So basically, just think of them as being false solutions. So any value of x that makes the denominator equal to 0 cannot be a solution to the equation. So that would be an extraneous solution. And so as we go through this, we're going to talk about the extraneous solution again. All right. Now, recall that a fraction is undefined if the denominator is equal to 0. And when a variable appears in the denominator of a fraction, we must restrict the values of the variable to avoid division by 0. So that was that discussion we just had. Okay, so now these are the steps. So there can be 5 steps, basically. And so step 1, you're going to simplify both sides of the equation. And so you can do that by clearing the fractions. So we'll be dealing with fractions, so we're not going to have any decimals in this particular lesson. So it'll just be fractions. So you can clear the fractions by multiplying both sides of the equation by the least common denominator, the LCD. And then you're going to remember the distributive property. You're going to have to recall the distributive properties to clear the parentheses. And then you combine like terms. So it's step 1. Step 2, Now remember we said a while ago that these are going to lead to linear equations. So step 2 is going to use the addition property of equality to collect the variable terms on one side and the constants to the other. So remember, these are leading to linear equations. That will be step 2. And then step 3 is to get the variable by itself. So that's where you can use the multiplication property of equality. And then step 4 is where you're going to check for extraneous solutions. And then step 5 is write the solution set. Okay? All right, so those are your steps. Okay, so let's look at this example here. Number 1. So I have this equation. First of all, I had to find the restrictions. So these are my restrictions. Okay, now we got to find step 1. Remember, was to find the LCD. So we got to find the LCD. That was step 1. Step 1, we have to find the LCD. All right, so LCD. All right, so to find the LCD, you're gonna factor all your denominators. So remember, this is a linear factor, a to the first, so that's linear. And we recall, if you don't remember how to factor very easily, and remember the purpose of this course is to remember how to factor. The factors of these are usually going to be these, not always, okay, but many times it will. So let's just check and see if this works. So I'm going to factor this as two binomials using these factors, a plus 3, a minus 2, and use a FOIL to check. So a times first, outer, inner, last. So a times a is a squared. The outer is negative 2a. The inner is 3a. When I add them up, I get a. And the last, positive 3 times negative 2 is negative 6. All right, so that works. Okay, now let's check up at the LCD. The LCD must include every factor you see. Every factor you see. Now, in a previous course, when we talked about LCD, it got a little bit more complicated. But for this right here, it's not that difficult. Okay, so it's just easy to remember. Every factor you use. So here's a factor, a plus 3. I got to use it. Here's another factor, a minus 2. I have to use it. Now let's go to this one. A plus 3, I already have it. A minus 2, I already have it. You're done. There's the LCD. Now remember, in the previous course, it got more complicated because in these rational expressions, when we talked about rational expressions, if you had exponents, you had to use those exponents as well. Exponents other than 1, excuse me. Okay, now that was part of step 1. Okay, now remember, still step 1. This is still step 1. We got to clear the fractions. Since they have fractions, I'm going to clear them. Now remember, this is an equation. What you do to one side, you do to the other. So listen carefully about what I'm about to do. All right, so I'm going to rewrite this over. 20 divided by a squared plus a minus 6 plus 6 divided by a plus 3 equal, and I'm going to leave some space here, right here, 5 divided by a minus 2. All right, now I want to clear these fractions. Because remember, I want to go to what's called a linear equation. So I'm going to go from a rational equation to a linear equation. So I'm going to clear these fractions. Since this side has 2 fractions, you see the 2 fractions? I'm going to put that in parentheses. Always put that in parentheses. That's only 1 fraction. You don't need parentheses. All right, now I'm going to take my LCD. I'm going to multiply both sides by it. So I'm going to say a plus 3, a minus 2. Just like that. Same thing here. What I do to one side, I do to the other. A plus 3, a minus 2. All right, so that's where I'm at. Okay, now, still step 1. So remember so I did this part. I'm trying to do this part. Okay? Now I'm going to use the distributive property to clear the parentheses. So I'm going to use the distributive property. Notice what's happening. So I'm going to distribute and multiply all these 2 fractions here, both fractions, by this. So that's the idea of the distributive property. All right, here, since that's just 1 fraction, that's not going to involve the distributive property. All right, so watch what's going to happen. So I'm going to take this, multiply by this. So a plus 3, a minus 2 times the first fraction. I'm going to go ahead and rewrite this in factored form. Always rewrite this in factored form. A plus 3, a minus 2. Plus this, this times this, so it'll be a plus 3, a minus 2 times 6 divided by a plus 3 equal, I'm going to rewrite this over, a plus 3, a minus 2 times 5 divided by a minus 2. Okay, so I use the distributive property. Now I'm going to simplify. I'm going to simplify this. All right, so notice what I mean by that. So what I mean by that is this. If I look at these factors here, the a plus 3's divide out. And when they divide out, I mean that their factors, the factors that are left are 1's. So a plus 3 divided by a plus 3 is 1. All right, anything divided by itself is 1. A minus 2 divided by a minus 2 is 1. So notice whenever I clear the fractions, remember I want to clear the fractions, these factors down here have to turn into 1's. Let's go here now. The only part I can reduce, I can simplify, is the a plus 3's. So a plus 3 divided by a plus 3 is 1. So remember, the whole point of multiplying by the LCD is to make these down here 1's. And then over here, the a minus 2 is my denominator. It's going to reduce with a minus 2 that's in the numerator, because anything divided by itself is 1. All right, now so that's what I have. Okay, now listen carefully. I'm still on step 1, according to this. Still in step 1. 1 times 1, remember this is 1 down here, so 1 times 1 times 20 is 20. So that's 20 right here. Plus, all right, now what I have here is, now be careful how you write this, 1 times a minus 2 times 6 is 6 times a minus 2. So notice that this is this, okay? Equal, and then a plus 3 times 1 times 5 is 5 times a plus 3. All right, so that's where I'm at. So notice I went from a rational equation to a linear equation. All right, now I'm going to have to use a distributive property again. So I'm going to distribute. Now be careful, what some students do is they'll say 20 plus 6 is 26 and distribute the 26. Remember, you can't do that. Order of operations says I got to do multiplication before I do addition. So you have to distribute first. So I get 20 plus 6a minus 12 equal, and then distribute here, I get 5a plus 15. Okay, so notice that I went from a rational equation to a linear equation. And so that was the end of step 1. So step 2 is where you're going to combine like terms. And then step 3 is to get the variable by itself. All right, so combine like terms. I get 20 and a negative 12 is 8. So I get 6a plus 8 equal. And then I cannot combine anything on this side, so I get 5a plus 15. And then I'm going to bring all the variables one side, constants to the other. So I'm going to subtract 5a from both sides. And so combine like terms again. 6a minus 5a is a plus 8 equal, this is 0. 0 plus 15 is 15. And then to get a by itself, I'm going to add 8, subtract 8 from both sides. And then combine like terms again. 8 minus 8 is 0, so I get a equal, and then 15 minus 8 is 7. So I get 8 to be 7. Now notice I didn't have to do step 3 here because the coefficient of a was 1 already. Alright, so a is 7. So that's my potential solution. Now when I say potential, I mean it's potential because I did have variables in the denominator. So all I got to do is look at my restrictions. Is 7 any of these? The answer is no. So I can use 7, and 7 does work. All right, so 7 is my solution. So the last step where it says write the solution set, so you would just say a equals 7. That's your answer. Okay? All right, now just to show you, if you check it, you'll see that when I substitute 7, both sides are equal to each other. So watch. Let's check. Now you don't have time to check on a test, but if this is a worksheet, you can check it, but you're not required to check it. So you got to go back to the original though. So I get 20 divided by, and remember I'm going to use the factor part here. So when A is 7, 7 plus 3 is 10 times, and then 7 minus 2 is 5. So this becomes 20 divided by 50 plus 6 divided by A is 7, so 7 plus 3 is 10. And then I want to see if that's going to equal this side, which is 5, divided by 7 minus 2, which is 5. All right, so let's go on this side. So let's reduce here. 20 over 50 is 2/5, plus 6/10 reduced is 3/5, and then that's just 1, right? 5 divided by 5 is 1. Now look at this. 2/5 plus 3/5, the denominator is already the same, so I just add the numerators. So I get 5 over 5, and 5 over 5 is equal to 1. Okay, so 7 is a solution. All right, so that's number 1. So that's how you do number 1. So notice it is pretty complicated, or not complicated, but pretty involved. There's a lot of stuff you have to do. All right, let's get the next example, number 2. Okay, number 2, let's solve this equation. All right, you have 3 divided by x minus 3 equal x divided by x minus 3 minus 3 divided by 2. All right, so notice I have an equation. It is a rational equation. And so the first step is to find the LCD. Remember step 1. You're going to find the LCD right here. Find the LCD. But before we find the LCD, we got to make sure that all the denominators are factored. What I want you to notice here is that this is a linear factor. X minus 3, you cannot factor this. It's linear, so leave it alone. And there's no common factors. All right, so you can't factor out a common factor. Here, same thing. This same thing as this one, and then this is just a number. All right, so you leave it as a number. So this is easy to do in terms of the LCD. So remember, every factor you see, you have to use. So x minus 3 is a factor. I have to use it and put that in parentheses since it's a binomial. X minus 3 is a factor. I already have it. 2 is a factor in my denominator. I got to use it. So this is the LCD. 2 times x minus 3. Now don't multiply it out. Leave it as 2 times x minus 3. Okay, so that was step 1. That's part of step 1, is to find the LCD. Okay, now what you're going to do is take this and you want to clear your fractions. So you're going to multiply both sides by it. All right, so just kind of remember the previous example. This is just one fraction, so I'm going to leave it as it is without parentheses, equal, and I'm going to leave some space here so I can put this. But see how you have two fractions and put that in parentheses. You have to put that in parentheses because you are going to use the distributive property. Okay, so now I'm going to take the LCD and multiply both sides by it. So you can say times 2 times x minus 3 equals 2 times x minus 3, just like that. Okay, now remember, as in previous example, you are going to have to use the distributive property here to get rid of these parentheses that you see here. So you're going to take this right here, and you're going to distribute. So let's do that step. So don't skip that step, actually do it, because if you skip it, you are probably going to mess up somewhere. Like some students, what they do is they see this and they divide that out and then distribute the 2, and that's wrong. You got to distribute this whole thing. All right, I'm just going to rewrite everything else as you see it. Just do one thing at a time very carefully so you don't mess up. Make sure everything's mathematically written correctly. All right, now let's distribute. So I'm going to say this, that I have circled, times the first fraction. Just like this. Minus, and then this that I have circled, times the second fraction. All right, so that's what I have. All right, now just like the previous example, you're going to reduce these. Remember, the whole point of multiplying by the LCD is to make these denominators 1. You want those to be 1s. All right, Now, so you're going to do that by using the idea of simplifying or reducing. So remember, x minus 3, this is division right here. So x minus 3 divided by itself is 1. So put 1s in their place so you don't mess up. Same thing here, x minus 3 divided by x minus 3 is 1. So you get factors of 1 in its place, because remember, 1 divided by 1 is 1. Here, you have 2 in the numerator, you have 2 in the denominator. I can reduce that, just like this. We put 1s in their place. All right, now let's look at what we have. 2 times 1 times 3 is 6. So that's just 6 right here. Equal. Notice the equal sign's aligned. Over here, 2 times 1 times x is 2x. Minus 1 times x minus 3 times 3. I'm going to rewrite this as this. Oops, just like that. So just go ahead and rewrite this since I still have parentheses here. All right, now be careful. What you're going to do here, see you still have parentheses, so you can use the distributive property again. But this time you're going to distribute the negative 3. All right, so here's what we get. Oh, before I go on, I want you to notice I went from a rational equation to a linear equation. Rational equation to linear. All right, so I get 6 equal 2x, and then we distribute the negative 3. So negative 3 times x is negative 3x, and then negative 3 times a negative 3 is a positive 9. Remember, negative times a negative is a positive. All right, so that was basically step 1 according to this. Now step 2, you're going to combine like terms. Oops, I'm sorry, that's step 1. So still step 1, combine like terms. All right, so still step 1. So 2x minus 3x is a negative x. So I get 6 equals negative x plus 9. All right, now step 2. I'm going to bring the variables one side, constant to the other. So I'm going to subtract 9 from both sides. 6 minus 9 is a negative 3 equal, remember this is 0, negative 9 and 9 is 0, and left with negative x though. All right, now remember, you've got to get x by itself. So now I'm going to do step 3, where I'm going to get the variable x by itself. So I have negative 1x. So the next step, I'm going to go ahead and rewrite this over. The next, remember this is understood to be negative 1 times x. So the next step is divide both sides by negative 1. So negative 1 divided by negative 1 is 1. 1 times x is x. And then negative 3 divided by negative 1 is a positive 3. All right, so that's my potential solution. Now remember though, oh, I forgot to do the restrictions. I'm so sorry. So let's do the restrictions. All right, so the restrictions, what makes this 0? It's very easy to see that what makes this 0 is 3, so x cannot equal 3. What makes it 0? X cannot equal 3. What makes it 0? This will never be 0. Notice there's no variable down here, right? That's always a 2, so it's never going to be 0. So there's only one restriction, 3, because 3 makes this 0, 3 makes this 0. So now let's go back over here. So this is my potential solution. This is not going to be a solution because 3 makes this denominator 0. That's a restriction. Now let's talk about extraneous. Remember the word extraneous? Where was it? It was in another area where we use the word extraneous. Oh, right here. So extraneous. So the idea of false. So this is a solution. See this right here? That's a solution to this linear equation. Because watch. 2 times 3 is 6. 2 times 3 is 6. I'm sorry. Yeah, 2 times 3 is 6. And then 3 minus 3 is 0. So 3 times 0 is 0. So 6 minus 0 is 0. And 6 does equal 6. So that is a solution. This here is a solution to this. But I'm trying to find the solution to the original. So I can't use x equals 3 for the solution to the original because it makes my denominator 0. All right, so that's the idea of that extraneous solution. Extraneous, that false solution. So you may say, well, I got a number for x. Yes, you did, but it's not a solution to the original. It's a solution to this one. The original had variables in it, so you got to check your restrictions. So I can't use x. Since that's the only number I got, I'm going to say no solution. So this equation has no solution. So don't say that's your solution. It's not. That's an extraneous root. extraneous, root, sometimes called solution, extraneous solution. So you can say extraneous root or extraneous solution. Does not matter which one you use. But since the only potential solution I got was this, and it is a restriction, I'm just going to say no solution. Okay? All right. So in some cases, when you look at these problems here, you will get no solution because your potential solution is a restriction. Okay, let's look at another example. Number 3. All right, so I have 5 divided by x squared minus 7x plus 12 minus 1 divided by x minus 3 equal 2 divided by x minus 4. Okay, now I got to find my restrictions. So to find the restrictions, you're going to have to factor your denominators. So I can't do anything here. X minus 3 is a linear factor, and I can't factor out anything other than 1. The GCF here is 1. GCF here is 1. Now remember what we said. So if you're having trouble with factoring, chances are the factors of this trinomial, this quadratic trinomial, are going to be these. So let's see if it is. X minus 3, x minus 4, and then use the FOIL. X times x is x squared. The outer is negative 4x. The inner is negative 3x. When I combine them, I get negative 7x. And negative 3 times a negative 4 is a positive 12. Okay? So I factor this is the same. It's going to be the factors of these. So now I can talk about the restrictions. So what makes the denominator 0? So what can't x be here? Well, what makes it 0? Well, x minus 3 is 0 when x is 3. You can look at that and see that 3 minus 3 is 0. What makes it 0? Well, 4 makes that 0. 4 minus 4 is 0. What makes it 0? 3. I already have it. What makes it 0? 4. I already have it. So how many restrictions are there? There are just 2. 2. All right, there are just 2 restrictions. All right, now we got to find the LCD. Once you find the restrictions, then you go to the LCD. Okay, now notice the LCD has to include every factor you see. Now these examples are easy because my factors will have exponents of 1s in these problems. In the previous course, you had more difficult examples. So my first factor I see is x minus 3. I have to use it. My next factor I see is x minus 4. I have to use it. The next factor I see is x minus 3. I already have it. Don't write it again. You already have it. X minus 4, I already have it. So if you write it again, it's no longer the LCD. It's just a common denominator. It's not the least, so you want the least. So only use it once. All right, so there's your LCD. Now the next step follows what we've done before. All right, so this has 2 fractions in it. So I'm going to put that in parentheses. So that the next step is where you're going to multiply both sides by the LCD. Now I'm going to go ahead and use these factored parts right here. X minus 3, x minus 4, minus 1 divided by x minus 3. Equal, leave some space here so I can put this, and then the next fraction, which is 2 divided by x minus 4. Okay, so I'm going to multiply both sides by the LCD. So I'm going to say x minus 3, x minus 4, x minus 3, x minus 4. So what you do to one side, you do to the other. Okay, now I got to get rid of these parentheses right here. These outside parentheses by using the distributive property. So I'm going to distribute this LCD through here. So both of these fractions have to be multiplied by the LCD. So what you're going to have is this now. You're going to say this, the LCD, times the first fraction. X minus 3, x minus 4, times the first fraction, minus the LCD times the second fraction. X minus 3, x minus 4, times 1 divided by x minus 3. Equal, I'm just going to rewrite this over. X minus 3, x minus 4, times 2 divided by x minus 4. Okay, now let's reduce. Next step is to reduce. Remember, the whole point of multiplying by the LCD is to get these denominators to be a 1. You want that to be a 1. Okay, so x minus 3 divided by x minus 3 is 1. Anything divided by itself is 1, so put 1s in their places. So these become factors of 1s. X minus 4 divided by x minus 4 is 1. So I have 1 times 5 is 5. Okay, now be careful here because you do have a subtraction. X minus 3's will reduce out, 1's in their place. Now be careful again, you have a subtraction here. So 1, forget about the subtraction for right now. 1 times x minus 4 times 1 is x minus 4, but leave it in parentheses, you're going to see why. So it becomes 5 minus x minus 4. Okay, be careful. Be careful with this one. Equal. And then here, the x minus 4's divide out. So I get x minus 3 times 1 times 2 is 2 times x minus 3. Leave the parentheses. Okay, now, let's talk about this for a moment. If you had not put parentheses here, the only thing you're subtracting would have been the x. So you would have said x, 5 minus x minus 4, but that's not correct. This is not supposed to become minus x minus 4. So when to distribute the negative 1, see that's when it should be negative 1. When to distribute this, this becomes 5 minus x plus 4. This is where you would have messed up. So you got to be careful. Make sure you leave that in parentheses just like I did this. See how I left in parentheses? Leave that in parentheses as well. So even though you have 1 times 1 is 1 versus 1 times 2 is 2, leave it in parentheses. The subtraction sometimes messes you up if you don't. So this is not supposed to be 5 minus x minus 4. It's supposed to be 5 minus x plus 4. So that's why the parentheses was important here. Over here, distribute the 2. I get 2x minus 6. So notice I went from a rational equation to a linear equation. All right, now let's combine like terms. 5 plus 4 is 9, so I get 9 minus x equal 2x minus 6. Bring the variables one side, constant to the other, so I'm going to add x to both sides. I get 9, this is 0, so 9 equals 3x minus 6. Adding 6 to both sides, 9 plus 6 is 15, so I get 15 equal, this is 0 here, negative 6 plus 6 is 0. And now, the next step, step 3, use the multiplication property to get the variable by itself. So the multiplication property of equality says, what I multiply on one side, I do the other, or what I divide on one side, I do the other. So I'm going to divide both sides by 3. And so 3 divided by 3 is 1. 1 times x is x, so I get x to be 5. Okay? So that's a potential solution. So remember, all you got to do, once you get this, all you have to do now is go back to your restrictions, see if that's one of your restrictions. It's not. So 5 will work. So 5 is a solution to this linear equation. It is also a solution to this rational equation because it's not a restriction. So your solution, you're going to say x equal 5. X equal 5. All right. Okay, let's do one more, number 4. So let's say my rational equation this time is this. M plus 11 divided by m squared minus 5m plus 4 equal 5 divided by m minus 4 minus 3 divided by m minus 1. Okay, now I have this rational equation. I have variables in the denominator, so I got to find my restrictions. So let's talk about restrictions. All right, restrictions. Okay, so I got to factor this trinomial. Chances are the factors of this trinomial are these linear factors. So let's check. Let's put this here, m minus 4, m minus 1, and let's use the FOIL method and see if we get this back. M times m is m squared. The outer is negative m. The inner is negative 4m. When I combine them, I get negative 5m. And the negative 4 times the negative 1 is a positive 4. Okay, so I factor this trinomial. Now let's do the restrictions. What makes this factor 0? Well, 4 minus 4 is 0, so m cannot equal 4. Let's go to the next one. What makes this factor 0? Well, when m is 1, because 1 minus 1 is 0. So far I have two restrictions. Let's go over here. Well, that is the same as this, and I already have it. So m minus 4, m cannot be 4. I already have it. Don't listen again. You already have it. Here, m cannot be 1. You already have it. All right, let's find the LCD. So the LCD must include every factor you see. So the first factor I see is m minus 4. I have to use it. The next factor I see is m minus 1. I have to use it. The next factor I see is m minus 4. I already have it. Don't list it again, because it's no longer the least. List it just once. M minus 1, I already have it. So there's your least common denominator. So your least common denominator has two factors, m minus 4 times m minus 1. Okay, now the next step is to multiply both sides by the LCD. Okay, so this is just one fraction. I'm not going to put in parentheses, but I'm going to leave some space here so I can write this. So m plus 11 divided by, and use the factored parts here. You use your factors here. So m minus 4, m minus 1 equal. Now leave some space for this. Now see how these are two fractions? Put that in parentheses because you're going to have to use the distributive property. Remember the distributive property? That's what you have to use. 5 divided by m minus 4 minus 3 divided by m minus 1. Okay, now let's multiply both sides by the LCD. So m minus 4, m minus 1, m minus 4, m minus 1. So what I do to one side, I do the other. Okay, now the next step is to reduce. Now before I do that, I'm going to have to distribute the LCD into this one here. Alright, so I'm going to rewrite this over. So I get m minus 4 times m minus 1 times your first fraction. Okay, equal. Alright, now here I'm going to distribute. So your LCD times your first fraction on this side. Minus or subtract the LCD times the second fraction that's on this side. Okay, so all I did was I multiplied both sides by the LCD, and I just, for right now, just distributed the LCD into this parentheses. Okay, now let's reduce. So remember, this is division. You can extend it. You'll see that's division right here. Becomes division. And then let's reduce. So m minus 4 divided by m minus 4 is 1. Anything divided by itself is 1. M minus 1 divided by m minus 1 is 1. So remember, the whole point of multiplying by the LCD is to get these to be 1s down here. Alright, so you got to make sure those are 1s. And notice what's left is just 1 times m plus 11 is m plus 11. That's all you have left. Equal. Over here, when I reduce, m minus 4 divided by m minus 4 is 1. And I'm left with 5 times m minus 1. Put that in parentheses, because you're now going to have to distribute the 5. Minus, subtract. Okay, now here you're going to divide, you're going to reduce the m minus 1s, put 1s there. And now be careful, your subtraction, so it'll be 3 times m minus 4 in parentheses, just like this. Okay, now let's distribute the negative 3's here as well. So I get m plus 11 equal 5 times m is 5m. 5 times a negative 1 is a negative 5. Here I'm distributing the negative 3. Negative 3 times m is a negative 3m. Negative 3 times a negative 4 is a positive 12. Okay, so notice I went from a rational equation to a linear equation. Okay, let's combine like terms on this side. So over here I get m plus 11 equal. Okay, 5m minus 3m is 2m. A negative 5 and a positive 12 is a positive 7. So I'm going to bring the variables one side, constant the other. Remember, that's how you solve a linear equation. So I'm going to subtract m from both sides. Combine like terms, this is 0, so I get 11 equal m plus 7. Subtract 7 from both sides. I get m subtract 7 is 4 equal m. All right, so that's a potential solution. Now, that is a solution to this linear equation. So that's why it's called extraneous now. This is going to be extraneous solution because it's not a solution to the original because it was a restriction. So since I only had one potential solution here and it is a restriction, you're going to say, yes, I'm going to have the word solution, and you're going to say no solution. Okay? So this equation has no solution because when you solved it, you got the potential solution to be 4, but that's a restriction. So now remember, this is called an extraneous solution. This is called extraneous. That's extraneous solution. All right. So it's an extraneous solution. Extraneous is a false solution. Remember the idea of false because it is a solution to the linear one, but it's not a solution to what I wanted to solve because it was a restriction. So you say no solution. That's what you write. Don't write the word extraneous solution. You write the word no solution. Okay. All right. So those were 4 examples. Hopefully that will help you with this lesson on solving rational equations. So it takes care of this lesson.